Welcome to the Deep Dive. We crack open stacks of fascinating sources to bring you the core insights, sometimes surprising truths, behind topics shaping our world. Today, we're plunging into something really foundational for, well, anyone building or even just trying to understand robust machine learning systems.
Yeah, absolutely key.
Experiment tracking and versioning. It sounds a bit technical, maybe, but it's about more than just good practice.
Not much more.
It's really about what makes or breaks an ML model's success out there in the real world. Our mission today: unpack why managing every single output from an ML experiment is, as the experts really stress, not just important, but absolutely crucial.
Couldn't agree more.
Okay, so let's unpack this. Experiment tracking and versioning in ML. Our sources mention that every experiment leaves behind this trail of outputs. Artifacts, they call them.
That's the term, yeah. Artifacts.
For someone imagining an ML model just kind of magically appearing, what exactly are these artifacts and why should we, the listener, care so much about them?
Right. Well, what's fascinating is these artifacts are basically the complete forensic record, the history of an ML model's entire life cycle.
Okay. Like evidence.
Exactly. Think of them not just as like leftover files, but as crucial pieces of evidence from every single iteration an engineer runs.
Every test, every tweak.
Every single one. When you're training, you're constantly tweaking, testing, observing, right? These artifacts are the data generated by that process. Things like loss curves showing how well it's learning, valuation metrics, accuracy, precision, that sort of thing.
Quantifying performance.
Precisely. Detailed training logs capturing every step, intermediate model checkpoints too, like snapshots of the model as it develops.
Okay.
And crucially, the specific hyperparameter configurations, those settings you tune to get the best performance.
The secret sauce, kinda.
In a way, yeah. And even visualization plots that help you see how the model's behaving. The bottom line, as the material really emphasizes, is without systematically collecting these, well, you're building in the dark.
Right. No way to trace your steps.
Exactly. You can't confidently know why a model performs the way it does.
So, okay, these artifacts are vital records, are breadcrumbs in this complex forest, as you put it. What's the actual cost then when they go missing? Or, aren't tracked systematically?
Oh, the cost is huge.
Because it sounds like in real-world ML production, the stakes are incredibly high. The pitfalls seem pretty severe.
They absolutely are, and it raises that important question. What does happen if a team just doesn't track this stuff? Systematically, I mean.
Yeah.
The consequences can be really far-reaching. Imagine a team iterating fast, running dozens of configurations.
Pretty standard stuff.
Totally. But without tracking, they quickly risk losing context, as the sources say. A common nightmare is having to start completely from scratch because you just can't recall which specific combination of hyperparameters actually gave you the best results.
Oh, wow. Or how performance changed during training.
Exactly. Because those critical logs weren't saved or linked properly. This leads straight to duplicated work.
Yeah.
I mean, I've seen teams unknowingly repeat experiments that someone else already tried.
Wasting time and resources.
Completely. And maybe those earlier experiments failed, or maybe they succeeded, but the findings just weren't recorded or easy to find.
And debugging. Must be a nightmare.
Oh, it becomes this Herculean task. If a model acts weirdly in production and you don't have that full history, it's like trying to fix a complex machine with no schematics. You're just guessing. And finally, this is getting more and more critical. It makes reproducing or auditing results later incredibly difficult. Think regulatory bodies, internal audits.
Right, compliance.
Yeah. If they ask how a model reached a decision or how performance evolved, and you don't have that verifiable trail, you're in a really tough spot. It just drains resources, drains time, turns a traceable process into chaos.
Okay, that paints a pretty vivid picture. Chaos, inefficiency. Sounds like it could easily derail a whole project.
Or impact competitiveness, absolutely.
Thankfully, it's not all doom and gloom. Our sources mention specific tools have emerged to tackle this very problem. ML flow, weights and biases, DVC.
Yeah, those are the big ones.
How do these tools actually help practitioners turn that chaos into order? How do they work in practice?
Well, they are genuine game changers. They provide the robust infrastructure for what we call artifact versioning and managing the whole experiment.
So instead of stuff scattered everywhere.
Exactly. Instead of being scattered, untracked, maybe living only on one developer's laptop, these tools offer a central, systematic way to manage everything.
Okay, like how?
Well, for instance, they let you automatically log all the parameters used for each experiment. and they link them directly to the result, performance.
So no guesswork about what settings led to what outcome.
Zero guesswork required. And beyond just parameters, they version the data sets and the models themselves. This is incredibly powerful.
Versioning the data, too.
Yes. So you have this precise, unchangeable record of which specific data version trained which specific model version. You can easily retrieve any past iteration.
Wow, okay, rollback capability.
Exactly. Imagine rolling back to a model from 6 months ago, knowing exactly the data it saw and the hyperparameters used. Plus, their visualization capabilities are key.
How so?
They let you see performance metrics over time and critically compare multiple runs side by side, visually.
So you can actually see the impact of changing a hyperparameter.
Precisely. You see how tweaking something affected accuracy or training time or loss across different experiments. It makes optimization much, much more efficient.
Right, it's not just logging, it's enabling that comparison and historical deep dive. That's a massive leap.
It really is.
Are these tools all the same fundamentally, or do they have different strengths?
Good question. They share core features, but often have, let's say, nuanced strengths. DVC, for instance, data version control, it really excels at versioning those large data sets alongside your code. Makes the whole pipeline reproducible.
Got it. Data focused.
Yeah. Weights and biases. It's really well known for its rich visualization dashboards, great collaborative features, makes it easy for teams to share, compare results.
More visual, collaborative.
And ML Flow tends to be a more comprehensive platform covering the whole ML lifecycle tracking, but also model registry, packaging project.
Oh, writer's code.
Exactly. But the key benefit, no matter which tool you pick, is that every piece of output generated is stored and retrievable systematically.
Avoiding all those pitfalls we talked about.
Right. And it enables smoother collaboration, ensures everyone's on the same page with versions, and, like we touched on, for regulated industries. This level of detail tracking is becoming absolutely vital for compliance.
Yeah, non-negotiable almost.
Increasingly so.
So let's zoom out. What does this all mean for you, the listener? Whether you're building models, leading a team, or just trying to grasp the practical side of AI in business, it really feels like more than just a technical detail.
Oh, absolutely. It connects to the bigger picture. Experiment tracking, artifact management. They aren't just nice-to-haves, not just best practices.
They're foundational.
They are foundational pillars
Yeah.
for building reliable, scalable, and transparent machine learning. As ML gets more complex, gets embedded in critical areas, healthcare, finance. That's very high stakes. Just getting a model to work isn't enough anymore. You need assurance it's reliable in production, that it can scale, and crucially, that its development is transparent, auditable. So proper experiment governance, it's not a luxury. It actually becomes a serious competitive advantage.
Yeah, so.
Advantage.
Well, think about it. Companies that master this, they can iterate faster on new ideas. They can pinpoint and fix issues quicker. Deploy models with more confidence, less risk.
Faster time to market, better products.
Exactly. Bring better AI products to market faster.
Yeah.
It fosters this culture of innovation, but built on a solid, traceable foundation. Without it, you're constantly fighting fires, second-guessing, struggling to scale.
Stuck in the weeds.
Pretty much. This is about embedding efficiency, trust, accountability right into the core of how you build and deploy AI. It clearly separates the leaders from those just, well, overwhelmed by the complexity.
What an illuminating dive, really, into the hidden backbone of robust ML. It's amazing how these seemingly small details tracking outputs, versioning artifacts, have such a massive foundational impact.
It truly is remarkable. It represents a fundamental shift in how we need to approach AI development.
Yeah.
And maybe here's a final thought to consider as you move forward. In this era where AI is becoming ubiquitous, touching almost everything,
Right.
how much will the public, regulators, demand not just impressive results, but verifiable, transparent, perfectly reproducible ones?
Good point. Proof, not just promises.
Exactly. The ability to perfectly recreate a model's entire journey from the initial data right through to deployment that might very soon become just as crucial as the model's performance itself. Something to think about.